Board theory. All right. So we'll do it like we normally do. We'll do a run through of the answers, and then we'll come back through for a more thorough walkthrough of the processes. And then, like I said, I've got an hour tonight, but if necessary, if I have to go, I can leave if there's still more questions you guys want to work, I can leave the room open for you to collaborate in even after I'm gone, and then it'll shut down after the last person leaves. Anybody have any questions, comments, thoughts, or concerns before we get into it? All right. Then the first requirement was to copy and paste our entire diagram from the ensembles lesson into a new diagram. And then on the second one, delete, don't know why, delete the partition, the data partition. I think this means containing the decision trees or connecting to the decision trees, and then add a new data partition directly after the data set. So why the removal and the addition, I don't know, but I did. And in the second decision tree, we changed the 2 model 6 branch, or the 2, what was it? 2 branch. Hey, Shaquille, what's up?
It's a good question on the first one. When you said remove and add back, so essentially it was same, right? That, I mean, I got also tripped on that, but I kind of said, okay, probably whatever it is, but essentially it's the second is a copy of the first one.
Yeah, if there was any kind of federation of configurations from the first to the second in that copy, I think they just wanted a fresh node. So I went ahead with it and got, I got results. So I didn't consider it a bad thing, but I was a little bit confused until I did some just inference, I guess. These are the diagrams that I got with and this was with the auto align configure button down here on the right. This is how they look when they're done. So I have the top model. Let me see if I can blow that up a little bit, make that a bit easier to read. There we go. So both diagrams have the data source, the German credit data source, the data partition, a start group for bagging and a start group for boosting, and then we have the 2 branch 6 deep and for both, and then the in group for bagging and boosting, and then an ensemble node connected to those in groups, a third decision tree for 2 branch 6 deep connected directly to the data partition, no boosting or bagging, and then a model comparison. And the only real difference between the top and the bottom is that new data partition node and changing the configuration of the decision trees to 4 branch 6 deep models tied to the same ensembles and model comparison. So that's my model or my diagram for this lab.
So there is a difference between the top and the bottom?
The differences between the top and the bottom are the new data partition node, and the decision trees were changed from 2 branch 6 deep up top to 4 branch 6 deep at the bottom.
Okay.
And so in total, there are 4 different models. There's each of the decision trees, then there's the ensemble of the ensembles, and then this standalone 4 branch 6 deep and 2 branch 6 deep. Clear as mud. Is that good, Shaquille?
I'm going to open up mine. Sorry, give me a minute. I'm just trying to make sure that I'm on the same page with you. So, in which question? I mean, where does it say that the second one should have 4 branches, the maximum? Okay, 4 branches. Okay, sorry. You can continue. Let me just.
Yeah. For number 2, we have the prompt is to provide the model comparison for the original diagram. So using the model comparison node for the original diagram from the walkthrough with the 2 branch 6 deep models, I came up now. I know that this may be different from mine, may be different from yours because I compared mine to others, but don't get hung up on the fact that our best model may be different. It may be a hardware issue, it may be a chipset issue, but as long as you've got something, you probably got something different than mine. Mine says that the Ensemble had the lowest test misclassification rate, and I ran that model. I rebuilt it 4 times. I ran it 4 times. Actually, I ran it 8 times, and I keep getting the same thing. And Dr. George is aware of the fact that I'm getting different results from other people. So I got the Ensemble was the preferred model with the lowest misclassification rate, and that the other 3 were trailing behind. Then
So
for
I got a decision tree with 0.28428.
yeah,
followed
yeah,
by
and
Ensemble
I
and
expect that. Yeah, does anybody else get the Ensemble, or is everybody else getting the 2 branch 6 deep decision tree for your optimal model?
You look at the test misclassification rate, right? The
Yes.
test. Okay,
Yep.
so I have the same to the ensemble for the first one, and
Well,
for the
good.
for the second one I have the decision tree.
Okay, where we expect there to be some differences, but Mintu, honestly, you're the first person I've spoken to that got the Ensemble as the same one that I got. So I'm encouraged by that. At least I'm not the only one out there with that answer. But
Hey, Tony, one question. In your model comparison, did you select any selection statistic, or it was default on the first one?
well, let me bring it up. This is lab 6.
Shakil, I got the same as yours. I know a few more people got that. So I don't think the selections are incorrect, in fact.
All right, for my model comparison for the top, I'm using misclassification rate and test as my selection table. What else were you asking about, Shaquille?
Yeah, is it true for everyone? Because I think I copied from the. Okay, so maybe that could.
From the walkthrough?
I mean, so are we supposed to use misclassification rate?
Yes, as far as I understood, I didn't see anything in the walkthrough instructions, but I'll bring that down just in case. Week 6. Which one is it? Screenshots. Where's my instructions? Why can't I find that PDF right now? That's bugging me.
Let me open for you. For the ensembles.
Yeah, which
no,
one?
1 second. So misclassification. No, yeah, 1 second. So I mean, it didn't have any instruction to change the model comparison to misclassification.
Yeah, but she's been expecting us to infer quite a bit.
Yeah. No, I'm with you. I'm just saying that.
Yeah.
Let me read on it.
Data partition, decision trees. Okay.
And the selection table should be test.
Yes. And yeah, as far as I can tell, it's supposed to be misclassification rate and test. I use testing. Did anybody use validation only or train and validation?
I think
I
you
use the
make sense.
default one. I use the default one, that is trained data set.
Yeah.
And yeah, my numbers are matching with you, Sakil. Means if I use the trained data set.
Same with me. I use the default, the train.
Yes.
I think either way probably should be fine.
Well, I don't.
Hmm.
I know she in the past she said, you know, don't rely on the results from the training set. So I'm trying not to. I'm either going to use validation or test. But if I can set aside a portion of the data and use the test data as a validation in a neural network or in machine learning, that's been the standard evaluation criteria. So I'm not going to say that any one way is right or wrong, but I'm going to stick with the test numbers as long as it's really the process. As long as our processes are good, our justifications are going to be our own. So
yeah, I agree. And if you can go back to the answer sheet. Yeah, so it is okay. So you're going with test because you ran with the test. Okay, now it makes sense. Got it.
All right. So for the new diagram with the 4 branch 6 deep, this is I got the 4 branch 6 deep was the recommended model with the best misclassification rate. For number 4 of the 8 models, because remember there's 4 per model cluster. I came up with the 4 branch 6 deep with 25.9% misclassification rate was my overall best model. And then if I was to run another 4 models with the intention of decreasing the misclassification rate, based on what I've already seen with these 8 models, what kind of decision tree would I try next? And I said I would do a 6 branch 6 deep. Because if the trend follows, then adding more branches should lower the misclassification rate further.
Tony, I think you know, like more brands, right? It's gonna be the misclassification will be lower. But actually, I do the model. It's not true. So you know, so I because I run another model for 6 branch 6 dip and 8 branch 6 dip, right?
Yeah.
And I see that the the result come out is not like what I expected. So I'm just like I don't know. It's so strange.
Well, then let's look at something here. If we take this model and not cut but copy,
Then
paste it down below here,
uh-huh.
and then let's look if we change this to, let's change this to 6 branch 6 deep.
Uh-huh.
And let's see what we get. It's gonna take a second to run it. But while it's running, we'll go on back into the document.
Okay. Thank you.
You're welcome. We'll keep that little window right there so you can see when it's done. All right, so then for part 2, a mid-size internet news website looking to change their banner advertising on websites. They have a data set containing information on 2,000 customers, indicating a customer had a web cookie from visiting 50 different websites. We have to sift through the data to identify patterns in the clustering of the customers based on their web browsing habits used in determining banner advertisement placement. So this is my final diagram. The clustering diagram includes both the baseball data source analysis as well as the analysis of the cookie data using the file import node. So these are my 2 final clusters. I just really took what was in the baseball diagram down here and kind of replicated it up top for the cookie diagram, and my clusters were 10 cluster, 5 cluster, and 10 centroid clusters. So that's that's what I got for my screenshot.
Yeah, that makes sense.
You guys have the same or close? Excellent.
Same.
Then for number 2, prepare a clustering model, this time setting the selection criterion final maximum nodes to 5. What are the top 4 most influential variables used for clustering in the cookie data set? I got YouTube, NFL, Facebook, and Twitter.
Yeah.
Anybody get anything different?
I have the same.
Okay.
So Tony, did you change that variable settings, or we're using the default one?
Yeah, I didn't change any variable or anything.
I didn't change any variable settings. No,
Okay.
I kind of left everything default.
Yeah,
If
I
they
have the same values. I have the same values.
Yeah, if they didn't ask for it or tell me to, I didn't do it. I
Okay.
had left that one alone. For
It's like
What's
I'm
that?
already having hard time with what they asked, or why should I do something they didn't ask?
yeah.
I'm just joking.
For number 3, this is my screenshot for the means plot with the 2 segment highlighted. And by highlighted, all I did was I clicked on the number 2 and it brought these out to the front with a little bit of a border around them. So that's the best I could do for highlight. I couldn't find any other way to make that more prominent, but
Yeah.
did
I did
anybody
the
else
same.
get anything different?
I did the same.
Okay, perfect. So then for number 4, describe segment 2. I said that the mean for segment 2 is below that of the overall mean, which is the blue, except for a number of significant outliers on the far right. Segment 2, along with the majority of other segments, appear heavily skewed to the left.
To the left?
What's that?
You said to the left?
Well,
to the
yes,
left?
heavily skewed to the left side of the chart. It's
Okay.
it's not an informative graph. There's too much information that's shoved over into the far left side, and none of this really means anything because you have all this over here just indecipherable.
So where did you get this first line? The mean for segment 2 is below that of the overall mean.
Well, I mean, if this blue is the mean and it's spread out through the center, then everything to the left is going to be lower than the mean.
I see.
We're talking about
I see.
our normalized mean scale at the bottom, where we're all over here, while the blue or the green, there's a little bit of orange, a little bit of yellow right here, but the majority of the observations are clustered right here along that origin axis.
Yeah.
It's not your typical XY chart. It's different websites and their mean. So it's all really kind of clustered around 0. And you need to have that, that logarithmic adjustment.
Makes sense.
So then for number 5, by copying the node, pasting it, renaming it, then changing the selection criteria final maximum to 10. This is just changing that cluster 5 to cluster 10 and running a new node. How does it compare? So adding the 5 additional nodes improved the distribution of means in relation to the overall and provided a more informative graph. This is and I did the same thing. I clicked on the 2, I highlighted it so that segment 2 stands out. But now it's at least interpretable, it's meaningful. You can see by website how the means are distributed across the graph. So it's a good adjustment. Increasing the nodes gave it better interpretability.
Okay, that makes sense.
And then this was my screenshot for the variable importance for that 10 node. And I've got these for, I don't think it asked for it, but I went ahead and put it there just for enrichment of the answer to show the differentiation, that not only did it change the distribution of means across the scale, but it also gave us 4 new top 4 sites based on those additional 5 clusters.
Yeah, I see that too. So I don't know that if I do it right or wrong.
Well, do you feel better now seeing this? Does this match what you
Yes,
thought, or-
yeah. I have the same, and because I look at the variable important, I want to see it, and I saw it changing like that. I say, oh, I don't know that I right or wrong on that. I feel better now. Thank you.
I know it's always good to have that reassurance, isn't it?
Yeah.
All right, then that's great. So for number 6, doing the same thing, copying and pasting the new node maximum 10, but changing it to a centroid clustering method. How does it compare to the interpretation of the primary attributes found in segment 2 for the first 2 attempts? And honestly, there was no visible benefit to doing so, to changing to centroid. Everything looks at observation, everything looks exactly the same. I was unable to find any significant difference. There may be some difference down here in the lower layers of this clustered mass to the left, but everything, I mean, I'm picking out specific pixels, observations, like this green one here matches this green one here. This purple one here matches that purple one there on top of the pink one. So everywhere I looked, about 20 or 30 different observations, they're all generally exactly the same. If they're off by maybe a degree, but not enough to make a significant difference. So that's what I said. The only real benefit came from adding the 5 nodes to the previous model. The centroid had no effect.
Let me run it again and confirm that. 1 second.
Was there more that you needed to see, Shaquille?
I'm running with the centroid. Just give me 1 second.
Okay. All right. If you come back to that when you get your results, and we'll compare.
Yeah.
Same top 4 for the centroid, and I if I remember correctly, it's the same numbers for the importance. 0.8776, 0.88531, 0.8776, 0.88531. So same graphic output, same variable importance, same top 4 variables. And that's lab 6. So going back to the top, and Shaquille, let me know when you want to take a look at those
Yeah.
graphs when you get results.
Yeah, just 1 more minute. I'm just almost done. Oh, that's okay. Sorry.
Was there something in particular, Shaquille?
I'm just copying do you want me to share and share the
Yeah,
screen and share?
let me stop sharing and go ahead and take over.
Okay, so I'm going to just share just to it says disabled participant sharing, screen sharing.
Oh, yeah, I'm sorry, dang, I'm sorry, man, I'm blanking there, sorry.
Never.
Okay, all right, I'm with you. I'm back on Earth.
Okay, so I'm sharing this to validate, not to say that I'm right or wrong. So this is exactly, I think, what she asked for. The top and the first and the second to me are the same, and I just did that. And then this one I'm going to change. I have changed the second one. I made it test by changing the default to misclassification. So I'm going to replace this one in a minute. It's running right now. Then this one, I have to complete this. So essentially, I'm saying that the misclassification rate is such and such of 2 branch 6 deep trees. The best model is the 4 branch 6, based on this one.
Yeah.
And then because the misclassification rate is better, I have to change the number. 1 second. I'll do that. And then what I did actually, I tried. So let me share 1 second. Instead of hypothetically saying, this is what I did. Let me show you guys. Okay, so what I did, I actually added this HP forest, and also I increased the depth to 12. So when I did that, I could see that it went down with Ensembles, 0.2575.
Okay.
Actually, all 4 of them were kind of same. I'm surprised why it only.
You got the same misclassification rate for 4 different models.
Yeah. Oh, by the way, that tells me that I need to probably change this one as well to test and then run it. Okay, that I'll do later. Okay, so that's that. And then in the clustering, same thing. Top 4 are YouTube, NFL, Facebook, Twitter. Then a screenshot of the input means with this segment 2 highlighted. I put this one. I'm not sure if it's required. Is it required to put this one as well, or I should remove it?
Your mean squared.
Basically, this segment to all the information about the related to segment 2.
Okay, this is.
It's this one.
Okay.
I think it's this one. This table mean statistics. Do we need that, or I mean?
At this point, it's your identification of the differences, and I was focusing more on the graphical differences and the fit statistics differences, and there's nothing wrong with pointing out the differences in that table amongst all the other clusters, but there's a lot going on there. There's a lot of different points of comparison on that table.
Yeah, I agree. So maybe it's probably confusing, this one. So I'll probably remove it. And then
actually, Shaki, when I watched the YouTube, they saying that we look at the maximum distance from the cluster, we interpreted that. So that's why that I talking about, I copy and paste that table, and I'm talking a little bit about that. And then when I look at the one from Tony, I say, oh, that one is good too. So I don't know.
Mhm.
Yeah, on the YouTube, they interpreted those things, whatever you have.
Okay.
Mhm.
Yeah, I'll probably remove it, I guess. This one, I need to explain. Thanks to you, Tony, for giving me some pointers how to describe segment 2. I'll use that. And then ran it again with node 10, maximum node 10. So
Yeah.
I think it's very similar to yours, Tony.
Yeah, let me take a look at yours real quick. We'll do a little side by side. Yours are more spread out than mine. You probably pulled it a little bit farther out than I did, but I think generally the shape is the same. I'm seeing the same clustering of certain pixels around each other. So yeah, I say generally we have the exact same graph, but yours is probably, you probably spread it out wider than I did, so you have more dispersal between the observations. But it's essentially it's the exact same thing.
Okay. And then I copied the variable importance
Yeah,
for this
and we got
one.
the same variables. We got the same numbers for the results.
Okay. And then the last one was this one. I have to just do the write-up. Basically, the variables are also same. The values are also same. So I'll just say no difference based on the graph and the variable importance.
Yep, it looks like we're kind of eye to eye there, Shaquille. We basically, aside from some visual differences in the size of our graphs, we have the exact same results in those.
Because we're best friends, Tony.
Exactly. That's right. That's what friendship does, buddy.
Okay, I have a question. When we because it's Shaki asking about setup for the variable. So when I look at the data, right? The data is just like 0 and 1. So what do you clarify for that? Is an interval or is a binary? Do you understand what I
Are you, Mentor, are you able to share your screen so I can see what you're working with?
I'm working on another laptop, so
Oh,
I have.
that's right. You work on two
Okay,
different
it's
computers.
just really simple. Okay, for the variable, right? So do you set up all of them is an interval? Because Shakil he asked the question on the email.
Yeah.
Yeah. So I just want to know that, because when I open the data, I see it's 0 and 1, 0 and 1 only. So in my mind, I think the input, those have to be the binary, right? Or what do you guys clarify is interval or binary?
Let me,
I get what you're saying, man. I actually set them as binary. So when you input your data in, I just convert all my interval variables to binary because they are classification 0s and 1s for if they have cookies on the website or not.
Yeah. So that's what I changed to binary, but I just want to make sure. So what do you guys put it in there?
I did the default. I mean, I didn't change anything.
So the default will be interval, but when you open the data, you will see it's just 0 and 1 because it's just like, okay, are you gonna, on that website or not, right? So you will answer the question.
Oh, for the
yes
good, good and bad, for good underscore bad.
Yeah, for the data that we download.
Yeah, 1 second. Let me make sure.
Mintu, I'm sharing my variables on screen. Are you able to see them?
No, on the other data set.
The cookie monster, I guess.
The cookie
Cookie
monster.
Yeah, the cookie.
Okay, 1 second. Which one was that? Lab 6.
That's the second one. The second, the cluster. Yeah.
No. Oh,
No.
you mean here?
The
The
clustering,
cluster one. Yeah.
the clustering and the cookie. Yeah.
I'm just trying to remember which.
The cookie monster. Yeah. And then, yeah.
Yeah,
Cookie
there we go.
monster
So Cookie Monster,
and
the
very,
variable,
yes.
everything is an input and everything is an interval.
See, if you open the data that we have, the cookie data, it's just 0 and 1. If you open the data, Excel,
The spreadsheet.
yeah,
Yeah,
the
I think because it's either 0 and 1, it's binary. Either they went to the site and got the cookie for that site or they didn't. So
Uh-huh.
it is a binary result for all those sites. It is going to be a 0 or 1.
uh-huh.
But I
But-
don't think you necessarily have to change everything to binary though, do you?
That's why I'm
Let's,
asking.
you know what? Let's
Yeah,
let's try.
so yeah, I changed it to binary, all of them.
Oh, very good point. Very good
It's
point.
not, it will not change too much on the result, but the thing is that the diagram, the picture is gonna change. The result will not change. I think I tested.
But I think that's actually a very good point. Does everyone agree? William, Sajal, Parna.
William, you with me, right?
Yeah, I did
Yeah.
the same because I checked so what I did was I checked the Excel file and I noticed they are all yes and no's, ones and zeros. They are categorical, binary. So that's why I changed it all to binary too.
Okay. How about the rest of the team? Should we change and rerun our graph?
The graph really didn't change. It was just basically the graph changed just a little bit, not a significant difference, but the numbers are
Mhm.
still similar.
You know,
I mean, to me, it makes sense though.
yeah, it does make sense. And I'm thinking like what we talked about with the gain of value or the uplift. You know, if there's a significant gain or if there's a significant uplift, then the changes are worthwhile. But if it's not, if it's negligible, then you're adding, more potential points of failure. But let me take a look at this cluster 5. And that is rowdy. Input means plot. There's a lot going on there. Is that what you are? Is that what you're seeing?
Yep, that's what it looks like.
Oh, I don't like that. I don't like that near as much as I liked it with as the input. This is crazy and this is crazy. And that's the 5. That's not even the 10. I wonder what the 10 looks like. Yeah, I mean,
Yeah, when you change it, it's gonna look crazy. I mean,
yeah,
compared to interval, but like because it's a I just want to understand that how to verify that. I mean, because it's you look at the data and you input your data, you have to have the correct
there's a sort of symmetry here if you look at it.
uh-huh.
And the shape of this, not necessarily exact symmetry, but the shape. It's an irregularity, and the fact that there was no change from the 5 to the 10, unlike the other one, I get the concept of binary, but if it's all binary, do we really need to identify it as binary? if there's no differentiation between any other type of data attribute. Because with the interval, yeah, we had some, clustering over here on the far left, and we had the distribution of the overall. But at least when we added the other clusters, it differentiated, it distributed those across the normalized means. But this has no differentiation. There's a symmetric, almost it's quasi-symmetrical structure here that's hanging out in both corners. I just don't think that the binary is, inferring from what I'm seeing, I don't think the binary is a good configuration for this model. I'm not saying that I'm right. I'm not saying that you're wrong. I'm just saying that I won't be changing my answers from interval to binary.
Fair point.
So while I'm at that, let me go back in here and change those all back.
Thank you. Oh.
I'm glad we checked. I'm glad we explored that. It's neat to see that, but if anything, it just made me more convinced that interval is the answer. So great question. And Mintu, going back to the model here, I created a 6-branch 6 deep, and I connected them, all 3 models, to one model comparison node and ran it, and these are my results. I got the 4-branch 6 was still the optimal model out of all those. Still has the lowest test misclassification rate. So any improvement, it's not happening in misclassification. So I don't know. I don't know if there is a number of branches or depth that would improve that. But as far as these decision trees and ensembles go, the old-fashioned 4-branch 6 deep is still the winner in that whole gathering.
I am with you on that. It's just like, are we gonna predict that 6-branch 6 deep is better, right? No, right?
Yeah.
I mean,
it makes logical sense when you think about the progression of improvement, but when you actually see it, no, it doesn't. It really doesn't add any benefit. Maybe here in the numbers we've got.
But in the ensemble model is improved.
Yeah.
Yeah. So should we say that the 6-branch 6 deep is good for ensemble only?
Well, then if 6-branch 6 deep is good, maybe as an ensemble, maybe adding those extra branches does improve the overall averaging, even if the individual averages are subpar. That would be a reasonable assumption or a reasonable explanation. But I'm also, yeah, it's hard to get anything out of the lift graphs with all these different models involved. But yeah, the ensemble, if there's an improvement anywhere, it's in the ensemble. So I think that would be valid. Now, folks, I hate to do this, but I gotta go. I'm at my time limit. Do you want me to leave the room open and you guys can discuss?
Before you go real quick, can I see your number 1 for part 2? I just want to look at it.
Part 2.
The clustering.
Okay, thank you, Tony.
You're welcome, Mintu. It's good talking to you.
Okay, that's it. That's all I wanted to see.
All right.
You good.
All right, William, good job.
All right.
Anybody else have anything else that they need to see or talk about?
No, I'm good. Thank you
All
very
right.
much. Actually.
Thank you very much, man.
Okay then. Have
All
a
right,
good
everybody. It was a pleasure. I hope you have a great rest of your weekend, and don't forget to turn in your assignments and also turn in your essay. That's tonight as well.
Thank you. Take care.
All right, you too. Take care, everybody.
Thank you, Tony.
You're very welcome, Sejul.